The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
After 25 years and over $10 billion on Christmas Day 2021, the James Webb Space Telescope was finally launched into space by a European Ariane 5 rocket.
Decollage liftoff from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe.
However, the James Webb Space Telescope has not only just arrived, but is rapidly changing the game. Scientists are amazed as they watch the Big Bang Theory crumble before the telescope's recent discovery. According to Michio Kaku, we might have to rewrite all the textbooks of the universe's formation, as 6 strange galaxies have just been captured, leaving scientists in confusion. So what's the truth about our universe? Keep watching to find out. Beyond the Earth, we see there is an incredible mass of space, likely limitless, which for the most part remains unexplored. But thanks to the many scientific researches and discoveries ongoing, we can at least appreciate the complexities of the world we live in as we question concepts about the universe and its formation, about our very own existence, and whether we are alone in this world or not. Questions like this have led to much research on space and investment in space technology. And so much has been done already with technologies like rockets and satellites orbiting our planet. Yet one of the biggest successes of astronomers and scientists alike in recent times is the James Webb Telescope. The James Webb Space Telescope, JWST, is a large space-based observatory designed to be the successor to the Hubble Space Telescope. It is a joint project of NASA, the European Space Agency (ESA), and the Canadian Space Agency (CSA). The telescope is named after James E. Webb, NASA's administrator during the Apollo program. The JWST is designed to observe the universe in the infrared portion of the electromagnetic spectrum, which allows it to peer through dust clouds and study distant objects with greater clarity than ever before. It has a primary mirror that is 6.5 meters, 21.3 feet in diameter, which is more than twice the size of Hubble's mirror. This large mirror will enable the JWST to gather more light and provide higher resolution images. The near-infrared camera NIRCam also provides sharp images of astronomical objects in the near-infrared range. It is used for a wide range of observations, including studying distant galaxies, the formation of stars and planets, and detecting exoplanets. The telescope's mid-infrared instrument, MIRI, operates in the mid-infrared range and will enable the JWST to study the early universe, the formation of stars and planetary systems, and the composition of exoplanet atmospheres. There's also the Near-Infrared Spectrograph, NIRSpec, designed to perform spectroscopic observations in the near-infrared range. It is used to study the formation and evolution of galaxies, stars' chemical compositions, and exoplanets' atmospheres. And finally, there is the Fine Guidance Sensor Near-Infrared Imager and Slitless Spectrograph, FGS NIRIS, which combines a fine guidance sensor and a near-infrared imager spectrograph. It provides precision pointing and stabilization for the telescope and will also carry out scientific observations, including studying exoplanets and the formation of stars. So far, the James Webb Telescope seems to be living up to and doing well above the expectations set for it. It not only provides us a clear insight into space truths, but has also been recently crumbling old established beliefs that we had about the universe. Recently, from the first set of data acquired by the James Webb Telescope released by NASA, 6 mysterious and shockingly ancient galaxies have been found. And regarding this, the renowned theoretical physicist Michio Kaku comments that we might have to rewrite all the scientific books on universe formation. But hey, how serious can this really be? You may be wondering this until you find that our favorite Big Bang Theory is in trouble this time. Recently, there has been an explosion of astronomers and scientists all over Twitter talking about the shocking discoveries that came with releasing the first set of data collected by the James Webb Telescope. From this data, scientists have identified ancient, strange galaxies that have left them scratching their heads. and the anticipation is growing stronger by the minute as these shocking discoveries mean one thing: we might have been wrong all along about our universe. And the major victim in this whole eruption of knowledge here is the Big Bang Theory, which gives us a detailed explanation of the beginning of our universe and how it has evolved, forming the numerous stars and galaxies that are familiar to us. And the shock for the entire world began with the recent release of the James Webb Telescope photos of 6 ancient galaxies that seem to have formed between 500 to 700 million years after the Big Bang. This formation period could have stirred up complete opposition if not for the available evidence that's before our eyes. According to the established galaxy formation model which we previously held dear, galaxies take billions of years to be formed. So it is shocking to discover that these galaxies have developed fully in 500 million years. The recent findings question our knowledge about the years it took galaxies to form and how early galaxies started to form in the universe. But for the recent discovery through the James Webb Telescope, the Big Bang Theory should have thrived in providing us answers. This theory is a widely accepted scientific explanation for the origin and evolution of the universe. According to the Big Bang Theory, the universe began as an extremely hot and dense singularity around 13.8 billion years ago. It then underwent a rapid expansion known as cosmic inflation, which caused the universe to cool and become less dense. The concept of the Big Bang Theory was first proposed by the Belgian physicist and Catholic priest Georges Lemaitre in the 1920s, based on the observations of the universe's expansion made by the astronomer Edwin Hubble. The term Big Bang was coined by the British astrophysicist Fred Hoyle, who initially used it to criticize the theory, but the name eventually stuck. According to this theory, matter and energy began to form as the universe expanded and cooled. After about 380,000 years, the universe became transparent to light, allowing photons to travel freely, and this event is known as cosmic microwave background radiation, CMB. The CMB is one of the strongest pieces of evidence supporting the Big Bang Theory, as it was predicted by the theory and later discovered in 1965. Now, as time progressed, matter and energy continued to clump together due to gravitational attraction, forming structures such as galaxies, stars, and planets. However, the distribution of matter in the universe was not uniform, with galaxies and galaxy clusters forming large-scale structures separated by vast cosmic voids. And the Big Bang Theory also explains the observed redshift in the light emitted by distant galaxies. As the universe expands, the wavelengths of light from these galaxies stretch, causing a shift toward the red end of the electromagnetic spectrum. This redshift serves as evidence for the ongoing expansion of the universe, and the story goes on and on. But let us consider the theory in the context of the recombination and reionization stage, as it could help you better grasp what we're talking about. The recombination phase covers the period in the history of the universe when the plasma of charged particles, mainly consisting of protons and electrons, cooled down enough for electrons to combine with protons, forming neutral hydrogen atoms. This occurred approximately 380,000 years after the Big Bang, when the temperature of the universe dropped to about 3,000 degrees Celsius. During the preceding era, known as the era of photon-baryon domination, photons, particles of light, constantly collided with charged particles, preventing them from freely moving and forming stable atoms. This scattering of photons kept the universe opaque. However, as the temperature decreased, the average energy of photons reduced, allowing them to travel longer distances without interacting with matter. At around 3,000 degrees Celsius, the temperature became low enough for electrons to bind with protons, forming neutral hydrogen atoms. This process, called recombination, led to the decoupling of photons from matter. Photons were then able to travel through space unimpeded, leading to the recombination event. The recombination event is of immense significance because it marks the point at which the cosmic microwave background radiation, CMB, was emitted. The CMB is the faint glow of radiation that permeates the universe, originating from the hot plasma of the early universe. After recombination, the universe entered a phase known as the Dark Ages because the universe became largely transparent to radiation. During this time, there was no significant light sources or ionizing radiation, And before this time, there were no stars or galaxies. However, around a few 100 million years after the Big Bang, the first stars and galaxies started to form. These objects emitted intense ultraviolet radiation, interacting with the intergalactic medium's neutral hydrogen atoms. The high-energy photons from stars were energetic enough to strip electrons from the hydrogen atoms, resulting in the ionization of neutral hydrogen. This process is called reionization. Reionization is considered a significant event because it marks the transition of the universe from a predominantly neutral state to an ionized state. This ionized gas allowed light to travel freely, making the universe again transparent. It also played a crucial role in the subsequent formation and evolution of galaxies and other large-scale structures in the universe. It is generally believed that reionization occurred gradually over several 100 million years, starting from small regions of the universe where the first luminous objects formed and eventually spreading throughout space. Now, when the first set of stars began to form, simple elements like hydrogen and helium came together to form them. They were gigantic stars. Since they didn't have heavier elements, these stars could be much bigger than our Sun, even dozens or hundreds of times its size. These were the first population 3 stars, but we could not see them yet because our telescopes were not powerful enough. Astronomers estimate that these first stars appeared about 560 million years after the Big Bang. Eventually, though, these first stars exploded as supernovae and even larger stars formed and exploded too. At that time, these stars had to end up being fireworks because of the universe's condition, and their composition made them temporal. It was therefore a common and violent occurrence to see stars explode, lighting up the entire universe during the reionization period. Most of the universe was hot plasma at that time. This is the fundamental belief of the Big Bang Theory. And over the years, the Big Bang Theory has been supported by various lines of evidence, including the observation of the CMB, the abundance of light elements, and the large-scale structure of the universe. And all our lives we've been taught and have read about this Big Bang Theory and built our beliefs around it. Nevertheless, the theory is crumbling now. But why do we say this? Well, it's all down to a discovery made by the James Webb Telescope. So what has been discovered from the James Webb Telescope to cause such a ruckus? Since the James Webb Telescope was launched in 2021, it quickly took the spotlight with its many brilliant photographs of space that have left scientists amazed. Among these photos are clear, mind-blowing pictures of Cassiopeia, a supernova, Uranus, Neptune, the pillars of creation, a Pandora cluster, and strange galaxies, all taken clearly and uniquely by the James Webb Telescope. These JWST images have so far provided us with a deeper understanding of space, but taking a step further, the most recent discovery by the James Webb Telescope has been breathtaking and is causing a major disruption of our long-standing beliefs in the science ecosystem. So what exact findings are we talking about here? Well, let's delve in. Recently, astonishing discoveries have been brought to the table by NASA using the groundbreaking James Webb Space Telescope to capture the strangest images in space, which has got everyone talking about our past and what to believe going forward. Here's the thing, thanks to the James Webb Telescope, scientists seem to have unveiled 4 of the strangest galaxies ever observed, located over 13 billion light-years away from Earth. This new discovery is quite amazing and somewhat almost unbelievable, as these galaxies provide a glimpse into the universe's infancy that's much different from what we expected. The time of the formation of these recently discovered galaxies happens to be just between 300 to 500 million years after the Big Bang, and this figure has greatly contradicted the current scientific understanding about the formation of galaxies, because at the time that these galaxies were said to have been created, no galaxy was expected to have formed or be forming in the universe. The shocking discovery of these galaxies could only mean that they formed during the Dark Ages and survived explosions. Clearly, from the provided evidence, the period when these galaxies have formed tallies with that of the Dark Ages when nothing was supposed to have existed yet. This exciting and remarkable revelation came from 2 recently published studies in the prestigious journal Nature. There has been so much excitement surrounding the new discovery of these galaxies, and this excitement is not unfounded, as previous studies using the JWST hinted at the existence of even older galaxies. However, these 4 newly confirmed ancient galaxies stand out from the rest. Astronomers have meticulously verified that these are primordial galaxies and not some other cosmic phenomenon masquerading as distant galaxies or nearby imposters. However, some scientists don't appreciate the fact that they may have been wrong for so long and argue that these newly discovered galaxies might be black holes. Well, how true can this be? For clarity, black holes are extremely dense objects with gravitational fields so strong that nothing, including light, can escape their gravitational pull. They are formed from the remnants of massive stars that have undergone a gravitational collapse and are frequently found in the centers of galaxies. When a massive star exhausts its nuclear fuel, it can no longer sustain the outward pressure generated by nuclear fusion, which counteracts the force of gravity. Without this pressure, gravity causes the star's core to collapse inward. The collapse releases enormous gravitational potential energy, leading to a supernova explosion. Different types of black holes can form depending on the collapsing star's mass. Once a black hole is formed, it has several defining characteristics. First, black holes have a region called the event horizon, the boundary beyond which nothing, including light, can escape. It represents the point of no return. At the center of a black hole lies a gravitational singularity, a point of infinite density and curvature where the laws of physics, as we currently understand them, break down. Black holes can be surrounded by an accretion disk of gas and dust that spirals into the black hole, and friction within the disk causes the material to heat up and emit radiation before it crosses the event horizon. But here is the interesting part. Even scientists attest the newly found galaxies cannot be black holes, or it would also defy our knowledge of black holes. So what other arguments are there? Then again, how did the James Webb Telescope spot these galaxies? Well, traditionally astronomers rely on color variations to estimate the redshift of nearby galaxies, which indicates their distance from us as the universe expands. However, this method becomes less reliable when exploring uncharted cosmic territories like those observed with the JWST. And so, in a remarkable display of technical prowess, the researchers employed detailed measurements of the galaxy's spectra, analyzing the range of light they emit across different frequencies. This allowed them to double-check the accuracy of the redshifts, ensuring the authenticity of these ancient galactic entities. These 4 galaxies exist in a remarkable epoch known as reionization, during which the first stars are believed to have emerged. And so, once the ages of the galaxies were determined, the researchers examined the size of their stars and found them to be relatively small compared to our own Milky Way galaxy. However, these galaxies displayed a surprising characteristic. They were fostering star formation at an astonishing rate. Study co-author Stéphane Charlot, a researcher at the Astrophysics Institute of Paris, expressed his surprise at this early stellar activity, which defied expectations. Additionally, the galaxies appear to lack complex elements, indicating that their stars still need to have enough time to create heavier elements. Instead, they primarily consist of the original hydrogen and helium atoms that pervaded the early universe. These findings highlight the rapid growth these ancient galaxies underwent in the mere 300 million years of their formation, leading Professor Peter van Dokkum to wittily conclude that the galaxies had to grow up fast indeed, even surpassing the longevity of sharks. Now, when the JWST was launched in December 2021, astronomers hoped that it would uncover the origins of the first galaxies. However, discoveries like these challenge previous assumptions and suggest that galaxies may have emerged earlier than previously imagined. In light of these breakthroughs, Professor van Dokkum speculates that the birth of the first galaxies might have occurred so early that even the JWST's capabilities cannot observe them. It is fascinating how scientific exploration continually reshapes our understanding of the origin of our galaxy and the universe. Thanks to the diligent efforts and rigorous research of scientists, we have gained invaluable perspectives that have helped establish our understanding of the solar system, the formation of planets, and predictions about the future. However, recent revelations from the James Webb Telescope indicate that scientists may have missed something crucial in analyzing the universe's formation based on the Big Bang theory. These astonishing new galaxies have become a challenge to our existing knowledge and leave us questioning the origins of these unexpected cosmic wonders. And following the trend of groundbreaking discoveries by NASA's James Webb Space Telescope, the telescope has gone further to unveil the universe's most ancient galaxy ever witnessed. And following the trend of groundbreaking discoveries by NASA's James Webb Space Telescope, the telescope has gone further to unveil the universe's most ancient galaxy ever witnessed. Following the 2 preprint papers released and posted to the scientific article repository detailing the earliest analysis of the situation, the image released by NASA shows what looks like a red blob in the distance. But this is not just an ordinary blob, but is currently the oldest known galaxy in the universe. It is known as Glass Z13, taking its name from its redshift distance. This extraordinary celestial entity was said to have emerged a mere 300 million years after the cataclysmic event known as the Big Bang, surpassing its predecessor, the remarkable GNZ11, by approximately 100 million years. Glass Z13 has now claimed the title of the oldest galaxy on record. And astounding astronomers, Glass Z13 is estimated to possess a mass exceeding 1 billion suns. Despite its colossal weight, though, this primordial galaxy is remarkably smaller than our own Milky Way, our familiar cosmic abode. While the Milky Way stretches across a vast expanse of about 100,000 light-years, Glass Z13 spans only a few thousand light-years. Remarkably, the diligent researchers also stumbled upon another neighboring entity, Glass Z11, which shares the same ancient age as its predecessor. Both galaxies boast relatively diminutive sizes, with Glass Z13 measuring approximately 1,600 light-years in width and Glass Z11 spanning 2,300 light-years. Astronomer Rohan Naidu expounded on these extraordinary findings, stating they have stumbled upon 2 compelling contenders for distant and ancient galaxies. The cosmic expanse between us and them is so immense that the universe was a mere few hundred million years old during their formation. And with the prospect of peering even deeper into the cosmic tapestry thanks to the James Webb Space Telescope, the potential to detect galaxies less than 200 million years old looms on the horizon. The researchers assert that this endeavor holds significant importance in accomplishing the JWST mission to forge a comprehensive spatial map, marking a pivotal milestone in our cosmic exploration. Apart from the discovery of the 4 strange clusters of galaxies alongside the oldest found galaxy, another shocking and weird-looking galaxy has also been discovered from the data released by the James Webb Telescope. This time, the galaxy is the tiniest galaxy ever found. According to scientists, it is in fact not supposed to exist. This goes against every previous model and standard understood to be met before a galaxy could exist. This galaxy is so small that it's only 16 kiloparsecs wide. This is one of the strangest things that's ever been seen in recent times. To understand how small the galaxy is, you could compare it to the size of our Milky Way, which is about 40,000 kiloparsec. The galaxy RxJ2129Z95 is seen at a redshift of 9.51. Because of the galaxy's distance, its image appears faint, but was boosted by a 2.5 billion light-year galaxy cluster's gravitational light. Besides its size, another surprising thing about this strange galaxy is how fast it creates stars. Indeed, this strange galaxy is a star factory, producing numerous stars in a race that's quite alarming and impossible for all the galaxies that are way bigger than it. The galaxy is said to have formed between 500 to 550 million years after the Big Bang, and while some people have questioned the claim that this is a galaxy and not a star cluster, all evidence has proven positive on this claim. While it is small for a galaxy, it's still way bigger than a mere star cluster. And while some scientists try to explain why this particular galaxy is creating more stars than can be called realistic, some speculate that there might be a mechanism at work whose cousin needs to create stars as fast as possible. On the other hand, it could be that we don't have it all figured out when understanding how stars form. But how did the James Webb Space Telescope manage to spot these ancient galaxies in the first place? Well, we must give it to the James Webb Telescope for its incredible ability to capture what its predecessors failed to capture. But how did it do it? Well, remember how the JWST detects infrared light. The whole process can be understood better using the redshift concept. But what is that? Redshift refers to the phenomenon where light from distant celestial objects, such as galaxies or quasars, appear to be shifted towards longer wavelengths, specifically towards the red end of the electromagnetic spectrum. Redshift is a consequence of the expansion of the universe. When an object in space moves away from an observer, the light it emits is stretched or stretched out as the space between the object and the observer expands. This stretching causes the wavelength of light to increase, leading to a shift towards longer wavelengths, which correspond to the red part of the spectrum. This is why it's called redshift. Redshift is closely related to the Doppler effect observed with sound waves. Similar to how the pitch of a sound changes as a source moves away or towards an observer, the wavelength of light changes as a source moves away or towards us in space. In the case of redshift, the wavelength of light is stretched due to the expansion of the universe. Redshift has important implications in cosmology. It provides evidence for the expansion of the universe and is used to measure the rate at which galaxies are moving away from us. The redshift of light from distant galaxies can be used to estimate their distance from Earth, allowing astronomers to study the large-scale structure and evolution of the universe. And it is amazing that all these strange discoveries of ancient galaxies long hidden away but now found and are causing so much uproar in the world of researchers and scientists is just part of the first batch of the James Webb Telescope's data released by NASA. This clearly demonstrates the peculiarities of the James Webb Telescope and its capabilities, and evidence that there is more to come with many more galaxies to be discovered. We can only anticipate. What do you think about these stunning, strange galaxies the James Webb Space Telescope captured? Let us know your thoughts in the comments section below.